Okay, guys, so we're going to continue on with lesson 7-8. Now that we know how to factor by grouping, now we're going to talk about factoring completely. So that means when you're given a polynomial that's either 2, 3, or 4 terms, binomial, trinomial, or 4 terms, we can factor it down to its linear factors if possible, or at least close to that. So for instance, we want to break it down as far as it goes. Okay, so something like this. That's what we're looking to do. So first step, they have them nicely marked out here. We always look for a GCF, no matter. Sometimes it applies, sometimes it doesn't, but always look for that first. Then see if there's a pattern. If there's a pattern that exists, apply it. If there isn't, then keep going. So if it's a trinomial, you're just going to factor. So assuming there's no pattern, then you're just going to go ahead and factor. You can either use the algorithm or the X method, either one. Or if you do your own thing, that's fine as well. And then last but not least, if it's a 4-term polynomial, you can't do our traditional pattern like we did here, or method like we did here, algorithm or X. Instead, you would just factor it by grouping. Okay? All right, so let's try a bunch. We're just going to practice these 2 here and then the 4 below. Okay, we're going to stop at that. So factor these completely. First step, I look for a GCF, and I notice 3 goes into everything. And they each have at least one x, so I can only pull one x out, and let's see what's left. 3x times x squared is 3x cubed. 3x times 2x is 6x squared. And 3x times negative 6 is negative 18x. Okay, so I've pulled out a GCF. Now I look and see, is this a pattern? So if I'm following these steps here, is this a perfect square trinomial? Is this a perfect square? Yes. Is negative 6 or 6? And no, 6 is not a perfect square. So this is not a pattern. So my next step is to go to the factoring method. I can either use an algorithm or the X method. I've been using this one just because it's easier to, I think, show on the computer. But again, whatever works for you is perfectly fine. So we're factoring this right here. So the factors of 1, and now we don't even really need to use the X pattern or the X method in this case. When we have a 1 here, we can kind of think through it. So X and X. Now, what multiplies to give me negative 6? Well, the only things that multiply to give me negative 6, again, knowing one's positive and one's negative, is I have a 1 and a 6 or a 2 and a 3. So, and they have to add to give me 2. Well, even if this is negative or if that's negative, they don't add to give me 2. And if I make this a negative, that adds to give me 1. If I make that a negative, it adds to give me negative 1. So actually, technically in this problem, nothing is going to add to give me 2. So this problem, and this is kind of an interesting thing, but it's important to know that this happened. It can't be factored any further than it is at that step there. So my final answer here is 3x, pulled out my GCF, and then x squared plus 2x minus 6. And I know that looks strange. You think you should be able to factor it, but you actually can't. Okay, so let me give you a little indication as to why that is. So x squared plus 2x minus 6. If I go to Desmos real fast, everyone's favorite, all right, I'm going to type that in. X squared plus 2x minus 6. Now, we know that if we solve these, our answer is where it crosses the x-axis. Is that a nice, neat number? Definitely not. And this point here, no. So again, chapters 8 and 9 will dig more into the connection between the polynomial and what the graph looks like. But if it's not crossing at a nice, neat point, it can't really be factored nice and neatly. Even fractions should usually come up somewhat decent. So that's a good indicator that that's factored as far as it can go. Okay? All right, let's try letter B. Now this one only has 2 terms. So in my head, I'm thinking maybe this is one of those, sorry, that's really sloppy, difference of 2 squares patterns. And we're going to talk about that in a minute if you forget what it is. But first and foremost, a GCF. So I can pull a 7 out. They both have 7 in common and 2 x's, so x squared. And then let's write what's next. Okay, so 7x squared times x squared equals 7x to the 4th. 7x squared times negative 4 gives us negative 28x squared. And so I factor that out. Now what I'm going to do is I'm going to look here and say, okay, well, I still have something left, and I might want to stop, but there's two terms. Is this a perfect square, and is that a perfect square? And they both are. So this actually goes one step further. I can write this as 7x squared. And remember, if it's a difference of two squares, you take the square root of the first value, which is going to be x and x, the square root of 4, which is 2 and 2, and then 1 is plus and 1 is minus. And that's what we're going to get as our answer. Okay? All right. When I look at that, these are as factored as far as they can go. We're done. Good work. All right, let's move on to the extra practice. Like before, feel free to pause it, try them yourself, give your own go at it, or just follow along with me. Okay, so I have two terms here. I'm going to first and always look for a GCF. I can pull 4c out. Excuse me, I'm going to have c squared minus 1 left. If I distribute 4c into both, I get this same thing back. Now the 4c stays out front, and I look, can this here be factored? Is this a perfect square? And is this a perfect square? And they both are. So I can take that, it's a difference of two squares, difference, subtraction of two different squares. So the square root of c squared is c, square root of 1 is 1, and 1's plus, 1 is minus. I'm factored. And if you're wondering, why do we do this? It will become clear in the next two chapters, because we're going to start looking at graphing them, and when you can factor things, you can get answers, and especially with word problems, it becomes very realistic and useful whenever you can get a value and it applies to a word problem. All right, moving on, number 6. If we take a look at this one. All right, so for number 6. So in this problem, I look and see, is there a GCF? And nothing goes into 2, 3, and negative 2, so no GCF. Then I like to see, is it a pattern? So is this a perfect square? Is this a perfect square? And neither are perfect squares. So the only thing I can do next, since it's a trinomial, is I can factor it. I can either use the algorithm or the x method. I'm going to use the x method, and again, that's because this first term is not a 1. So I'm going to put 1 and 2 here. Now my factors of negative 2 are only 1 and 2. One's positive, one's negative. And I need them to add to give me a 3. So if I try 1 and 2, 1 times 2 is 2. 2 times 1 is 2. Knowing that one's positive and one's negative, it doesn't matter which is which, that's going to give me a 0. So that doesn't work. Okay, so hopefully, if you're using this method, hopefully by this point you're getting a little fast. You don't need to write it out. But if you're still, I know it's hard because I can't interact super clearly with you to get an idea of how well you're understanding it. But if you're not getting it, feel free to ask me if this is the method you prefer and you want some help with it. On some shortcuts, okay? But anyway, 1 times 1 is 1, 2 times 2 is 4. Knowing that one's positive, one's negative, and I have to get to 3, if that negative is with the 1, negative 1 plus 4 is 3. So I'm going to put the negative with the 1. 1 times 1 is negative 1, 2 times 2 is 4, and there's my answer. So when I factor this, I take what's across the top, which is a plus 2, 1a plus 2, and I take the second across the bottom, 2a minus 1, and there's my answer. Okay? All right, let's try number 7. For this one, I'm going to look for a GCF, see what it is that we're given. Okay? And when I look at that, I can factor out a GCF of 25, which is pretty big, and then x squared. All right, 25 times 4 is 100. X squared times x squared is x to the 4th, minus 25 times 1 is 25, x squared times 1 is x squared. All right, then I do 25x squared. Now this, the reason I keep going is because, again, I always want to see, is this a pattern, what's left? And that is a perfect difference of two squares, meaning the square root of 4x, I know, 4x squared, sorry, is 2x. Square root of 1 is 1, and then I have a plus and a minus. And that's the end answer. All right, the last one we're going to do together is number 8. I look for a GCF to start. I can factor out a 2, but I can also factor a 4 out. So let's factor a 4 out and see what's left. 4 times 3x squared gives me 12x squared. 4 times negative 5x gives me negative 20x. And 4 times negative 12 is negative 48. Now I look and see, is this a special pattern? Meaning, is my first term a perfect square? And no, it's not. 3x squared is not a perfect square, nor is negative 12. So not a special pattern, unfortunately. But instead, I can just go ahead and do the x method, or what I prefer. 1 and 3 for my factors of 3. So in terms of what I'm doing here is I'm setting this up. The 4 stays out there. And now factors of negative 12. We have 1 and 12, 2 and 6, 3 and 4. Now just looking at it, 1 and 12 aren't going to work, so I'm not going to even work them out. 2 and 6, let's try it. So 1 times 6 is 6, 2 times 6, 3 times 2 is 6. That doesn't work. Okay, so let's flip the order. Maybe it's 6 and then 2. Just glancing at it, 6 and 3 is 18. That's not going to get me to this negative 5 that I need. So I'm going to move on to my last possibility, which is 3 and 4. 1 times 4 is 4. 3 times 3 is 9. Ooh, and knowing that 1 is positive, 1's negative, I can make this a negative 9, and that's going to add to give me negative 5, which is what I want. 4 and negative 9 is negative 5. Oops, sorry. Okay, so I'm going to make that a negative 3. So the top is x minus 3, and the bottom is 3x plus 4. And always feel free to go back through, FOIL it, make sure you have it on the right track, but these all worked. And so great work. Try the homework that's assigned. I'm not grading these for accuracy. I just want to get a gauge for how well you're doing. If you have any questions, like always, give me an email, stop into Blackboard Collaborate, and we'll be happy to go through things together. Thanks, guys. Bye-bye.